right, linear relations. So now we're going to put it all together, the graphing, the tables, the equations, and answer questions. So, example 1. A photographer charges $40 for a sitting fee plus $20 per sheet of prints. The charges are shown in the table and in the graph. So you can see that if you don't order any sheets, you get charged $40. And then for each sheet, it's an additional $20. So you can see that this is going up by $20. Can you order part of a sheet? No. So the points on the graph are not joined with a line. Normally, if you could have partial sheets, you could actually, make this a line. But because you can't buy part of a sheet, you cannot, they are just points on the graph. Notice that they look like they would form a line, but you cannot connect them with a line because the data, we say the data are discrete, meaning they're not a continuous from point to point. There's not part of a sheet in this case. For different values of n, we get different values of c. So the variable c, meaning cost, depends on the value of the variable n. When two variables are related in this way, they form a relation. When the graph of the relation is a straight line, or looks like a straight line, even though it's not connected dot to dot, it's called a linear relation. And in many years coming in your math career, you're going to learn different relations. Linear is going to be this year. Next year, you'll continue with linear. Grade 11, if you take pre-cal, you're going to get into what's called quadratic relations. And then in grade 12, you'll do a lot, like exponential, you'll do rationals, radicals. There's a whole bunch of different relations you'll do. All right, moving on. A popular DVD club allows members to purchase DVDs at a reduced rate price according to the table. So if you buy one, it costs $20. If you buy two, it's $25. It looks like it's going up by 5. So if we were to plot this on the graph, you would see that at 1, it's at $20. At 2, it's at 25. At 3, it's at 30. And at 4, it's at 35. Then you got to ask yourself, would I be connecting the points to make a line? Can I buy partial DVDs? No, you cannot. So we cannot connect these dots. So graph the data. Should the points be joined? No. Since you can't buy a part or partial DVD. Is the relation linear? Yes. It forms a line. We don't draw the line because we don't connect it, but we could. Describe the patterns in the table. How are the patterns shown on the graph? So for every DVD you buy, so how about this? For every DVD you buy, the cost goes up by, how much was it? It was $5, wasn't it? Let me check. Yeah, it was $5. Okay, so now we're going to graph the table of values. It looks like it's the number of floors and the height of the building. So the number of floors. One floor means it's 5. So notice there's not a 5 there, so I'm going to plot it between 4 and 6. At 2, it's 8. That's pretty obvious where to plot it. 3, it is at 11. And 4, it's at 14. So you can see visually this forms a line. So is this relation linear? Yes. For every increased floor, the height goes up by a constant amount. Goes up by what constant amount? Looks like it's going up by 3 meters. And so you can tell if something's a linear relation. If you can't graph it, you can look at the chart, and if it's going up by a constant amount, for every constant amount that it depends on, then you know it's a linear relation as well. Should the points on the graph be joined with a line? No, you can't have part of a floor. Okay, now we're going to complete the table of values. So I'm hoping you've seen a table of values before. Maybe not stated with an equation here like y equals 4x minus 2. But the way this works is you're taking what they give you for x and you're subbing it in for this expression, and then that's how you're getting your y. So they've done the first two for you, but just for fun, we're going to do it ourselves as well. So if I sub when x is -1, do you see y would be 4 times -1 subtract 2? And you have to do multiplication before subtraction, so this would be -4 subtract 2 gives me -6, just like they had there. When x is 0, y equals 4 times 0 subtract 2. So this is 0 subtract 2 gives me -2, just like they had there. When x equals 1, y equals 4 times 1 subtract 2. So that's 4 subtract 2 gives me 2. When x is 2, y equals 4 times 2 subtract 2, which is 8 subtract 2 gives me 6. Now, notice that the x's are going up by 1, and the y's correspond by going up by 4. Notice that 4 is part of the equation. We knew that from before. And then our starting amount is that -2. It's all relating to each other. So now we're going to plot this. So watch the scale of this coordinate grid, though. Look at the x-axis is going, you have kind of 2 squares for each one. So -1, -6, right there. 0, -2, right there. 1, 2, and then 2, 6. So you can see it forms a line. Now, can we connect the dots? Yes. Why? Because you can have partial x's. You can have x is 2.1, right? You can have all that. So then we take a ruler and we indicate it's a line by putting arrows on it because it goes on forever. We've only done a small snapshot of this line by picking x values from -1 to 2, but we could be picking x is 100, but you wouldn't because it would be too hard to graph. But I'm just saying that it doesn't matter which x values you plot, just pick some in a row. More often people pick 0, 1, 2. At least 3. Why 3? Because 2, you can make a line anywhere, but 3, they have to actually correspond in a linear fashion for it to be correct. So that's why I always say you need to do at least 3 points, and then you have to connect it with a ruler and put arrowheads on it to get full marks.